my name is Charlie Lagervik. I work as a global black belt at IoT, and today we have prepared a presentation around IoT and buildings. So I'm going to start by setting the context around the changes we see from a Microsoft standpoint in the building industry and also around the modern workplace. And then I'm going to give the word to Erik Wallin, that is working for Vasakronan and is also the founder of Klipsk, that is building a knowledge graph that is really the center of combining the different systems that we see around buildings. So we expect to have a presentation where we really showcase something innovative that we are building around the knowledge graph for combining the different islands of information and data in a building industry. So if we look at the building industry today, there is an increased demand and interest around what we call the smart spaces. And this is driven by many different market forces. It's both around the forces of lowering the energy consumption, and that is partly driven also by the pressure of minimizing the cost, but there is also environmental and sustainability factors that play to have facility owners and tenants to really focus on energy efficiency of today's buildings. There is also a trend when it comes to office space and workplace, that the workplace today is much more flexible. Work is not necessarily something you go to, work is something that you do, and your digital workplace is starting to get more and more important for the knowledge workers of today, and the integration with the current buildings are starting to become a challenge, both for the tenants, but also for the companies that actually owns buildings, that the leasing contracts are becoming shorter, you have higher requirements for flexibility, etc. So if we look at a pyramid of the different systems that exist in a facilities world, we have the building operation infrastructure. So this is generally power, ventilation, core infrastructure of a building. These tend to be real-time systems that are managed by companies like Schneider, ABB, and General Electric, for example. If we move up a little, we have also more and more systems that start to make a building more intelligent, more communicative. We have security systems, smart signage, all kinds of access control systems to understand also on the higher level how the spaces are used, which time of the day, and by using that information you could also then be smarter around how you optimize the energy consumption, the ventilation, and the core systems of the buildings. And top of this, we have what we see an engagement need. So that's the knowledge worker that is part of this building. And in the Microsoft world, this is the Office 365 platform where our customers are working on the digital workplace of Office. So there is a need, an increased need from the engagement users, the knowledge worker, to get a stronger integration with the lower level systems of the facility. And today these systems are poorly integrated. And to be able to integrate this, there is a lot of security concerns, of course, but there is also the semantics of the data. How could we in an efficient way actually integrate those low level systems so they mean something in the context of a knowledge worker? So if we look at the cost around these, and sorry for having this in square foot and in dollars. I work at an American company, so that's how it is. Energy is around $3 per square foot as a cost for a building. And if we look at the leased space, or the cost for leasing space, that tend to be 10 times more. But if you then look at the total cost of the people that is actually part of the building and is actually the ones who generate value in the building, the cost of having these productive workers, it's 100 times the energy cost. So there is an increased opportunity to actually focus on those high-level scenarios to make people more efficient when they consume buildings. And to be able to do this, you need to have the data around the people. And today in the Office graph, so that's the graph, the data model around your digital workplace, you could find information like who you collaborate with, who is your manager, which documents do I open, which meetings do I attend, and also which meeting rooms do I actually use. And then if we add to this graph the building information from the IoT platforms, you could start to do all kinds of intelligent things with AI around your IoT data, combining your digital world with your physical world. But to be able to do this, you really need to build a digital representation of the person. You cannot infuse AI to this data if you don't understand the data. So you need to understand things like the context of the person. What is the person wanting to do? And then understand the intent also of that person to be able to support them with that ambient intelligence. And to be able to do this, you really need to have a knowledge graph that supports the AI and supports the integration of these systems. And that's where Eric and Clips come in.
Thank you, Charlie, very much. Let me see if we got that one right. We didn't. Once more. There you go. Erik Wallin is my name. I'm working very closely with Vasakronan, and we have two products. One that we have branded Iden, which is an implementation for a smart building platform on top of Azure, the Microsoft Azure. And we have the real estate core, which is a consortium for the semantics. What I would say it makes us a little bit focused is that we are working exclusively with the problems with the perspective of a building from a building owner, from a large building owner, not from an IoT vendor or from a vendor that sells the system that makes the climate nice in here, but just from the perspective of the building owner. And I mean, we can't really have a presentation without an architecture image, right? I mean, this is my favorite. This is what we have been working very hard. I have to move a little bit here and see if I can find the pointer. I mean, this is what we have been doing at Vasakronan. We're using the Microsoft Azure platform, and I just take this very brief. I don't know, since you're here, you're probably familiar with buildings or with the Azure platforms a little bit. In the building, you have field buses, the ones that are actually controlling climate and access controls and lighting, etc. in the buildings. And you usually you want it's not that a big investment, but still it's a significant part of the cost of a building, and you want them to live for roughly 25 years before you start changing them. So you're not really taking a building like this and just ripping all of the systems out and putting in new ones. So you have pointer, nope. You have to push. There it was. So you have the field side, which is a huge cost for us when we're building this kind of system to integrate with the old systems. And we have found that working with a framework for edge computing, we have chosen to work with Microsoft IoT Edge Framework, has helped us significantly to work with Modbus and KNX buses, with those kind of old buses. Then we have the cloud side, which is based on Azure IoT Hub, which is Microsoft's packaging of different components in their cloud. It's basically a message broker. And then we have all the different storages within this. And the other important part is where we're putting extremely much effort in is on the API side, because these parts are just a cost for us. It's when you come to the application side where we start to see where we actually get something back. This approach of actually investing quite heavily in the API, building good documentation and good SDKs, gives us the benefit of actually connecting and using any vendor. We get so many requests from different tenants of, I wouldn't say crazy ideas, but ideas we never thought of different kind of use of the data. So we are actually today delivering data back to the tenants and charging them for that. So we are starting to finding new revenue streams, not just from square meters that we have in our old business model. Well, I'd love to talk much more about this one, because this is really the summary of what we're doing and what we have done. But I see that time is flying by. The IoT Edge Framework that we are using is an open source. Microsoft has open sourced the IoT framework, which was very important for us. And what we are doing here is that we are it's basically a message broker as well, but you can run it in Microsoft's cloud, or you can run it on basically any hardware platform. We are running it on Raspberry Pis, on different VM virtual machines, on PCs. But here's an example of how we are cooperating with Schneider. Schneider's product for building automation is called Structureware, where we actually have, in a cooperation with them, have them building this adapter, this component to the IoT Edge framework. So we are actually lowering our costs of operations and maintenance by having the suppliers to comply and deliver to this framework. We are really trying to set an ecosystem, to get an ecosystem to start moving forward, because it's quite costly for us. We have roughly 30 different versions of control systems in our buildings, since we are buying and selling buildings all the time. And it would be very expensive for us to build connectors and integrations to all of those. And then again, one of the benefits of us using an edge framework, an edge computing framework, is that we can put small, inexpensive computers or bigger computers out in the buildings to do things that can't really wait 1 second for a reply from the cloud, or it's too expensive to run the operations in the cloud. So we can actually pre-process data. Out here, we are also doing this the semantic transformation of the data. So it's called temperature when it's actually going into Eden, into the Azure platform. It's not called T or temp or something else. It's called temperature, plain and simple, as an example. The thing that makes this possible is the real estate core. The real estate core is English for buildings. And I mean, there are plenty of different standards when it comes to standardize smart cities, smart grids, buildings, all the new buildings. What we're trying to do here is that we are trying to take the perspective of the building owner again. What problems are we trying to solve? And in order to do this, we can't do this by ourselves. So we have done a consortium with a couple of other major property owners as a start in the Nordics. So we are all contributing, we're sharing the workload, and we are going to share this. We're going to publish this as open source before the summer. And I mean, this is really what we need in order not just to have, we have so many proof of concepts here and there in our companies, in all these companies. What we're trying to do here is actually trying to make them, to connect them together so we actually can scale. Vasakronan has roughly 200 buildings and 2.5 million square meters. And they are really different, all the buildings. Sorry about that one. The real estate core focuses on 3 different areas. It's actually to bridge over 3 very important domains. We have BIM, Building Information Management or Modeling. I don't know if you're familiar with that, but that is actually the digital twin of a building, but it's basically a system for planning and constructing building, and then tearing them down, disposing of them. It has very little focus on actually running the buildings for 100 years or 200 years. The second, but that is extremely important because we have very much information in this digital representation of the buildings that we want to reuse. Then is the control, all the control systems, climate, access control, lighting, etc. And then we have all the new technologies and methods that are challenging and helping us all the time that is coming from the IoT arena. So we basically see, and I mean, as I said before, you can't really justify to replacing a control system in a building before it's roughly 25 years old. So we have plenty of buildings that have older systems where the one that runs the buildings are more or less blind. They don't really know what's going on. They can get complaints that it's too cold, too warm, the air is too bad, too good. So what we're doing there is that we're using very much IoT technologies to putting out battery sensors. We are using LoRa networks quite much. We are trying out 2 different vendors. We are looking into using the next step that 5G will promise in narrowband IoT technology, just to solve how could we deploy and gather data in a massive sense. But basically, what we're trying to do is trying to get some sort of English for buildings. So we as a property owner can scale our buildings, and so we also can interact with the smart city, with transportations, rescues, operations, all kind of planning. And again, I think I have mentioned a couple of these, but since this is so important, it really needs to be repeated, or it doesn't. It can be repeated. The big thing with using this kind of semantic is that we can't scale without this. We can only just do proof of concepts if we can't have a common language that handles all the data that we are creating in our buildings. I can say that we see, when we are looking at a fairly newly produced building, we have roughly 0.4 data points per square meter. So if we have a building, or actually, no, we actually have more. We have a couple of buildings just next to us here. I think we are up on 0.6 only on climate systems. Then we have lightnings and passage. So we see that we will roughly have one data point, one sensor per square meter. So that is 2.5 million sensors that are constantly reporting data, and that's only building sensors. I'll show you a little bit what we have done with this. On the application side, here is where we actually start to turning all the data into knowledge. We're using Power BI, one of many products to do ad hoc analysis or do dashboards. And we are using, here's an example of an effect, a power signature of actually, I think it's the Kista Science Tower, the big tower that we see just a couple of 100 meters in that direction. And this is an example of how we fairly quick, I think the Power BI guy that did this, the data scientist that did this, did it in a day or something, the first one of those. And this gives, when we have the data on this real estate core, it's quite simple to do this. And then we take it to the ones that should actually do something good with this knowledge, and you can very easily just tune it a little bit to see what is the important information. And this is things, as you can see here, this is not done by designers. This is done just by engineers. And if you're looking at other examples of Power BI, can you see it was a little bit weak, but what it's supposed to be, there are floor plans of a building with, and I think in this case it's actually LoRa sensors. It doesn't really matter in this solution where the data comes from, but this is extremely useful for the people operating and running the building. And the one on top that says Vasakronan there is actually the dashboard on the information screens at the local headquarters in Uppsala of how much energy the solar, the photovoltaic system on the roof is doing. Oops, sorry, I see that. I'm ready.